In this module, we're going to look at molar mass. So we're going to be considering dimensional analysis skills for compounds. Molar mass for elements we learned last unit is that we have a periodic table entry. The number below the symbol on our periodic table tells us how many grams are in 1 mole. So for oxygen, 1 mole of oxygen would be equal to 15.999 grams of oxygen. For carbon, 1 mole of carbon would be equal to 12.011 grams of carbon. For sodium, 1 mole of sodium would be equal to 22.990 grams of sodium. And for right now, I'm just going to use every digit my periodic table entry gives me. To apply this to compounds, we just have to know the formula. So I could say that I'm working with sodium carbonate. Using our ionic nomenclature rules, I would see that the formula for sodium carbonate is Na2CO3. Now what that means is if I have 1 sodium carbonate, there are 2 sodium atoms in that molecule. In my 1 sodium carbonate, there is 1 carbon atom in that molecule. And in my 1 sodium carbonate, there are 3 oxygen atoms in that molecule. So going to molar mass, I know that 1 mole of sodium carbonate would start with having 2 times the molar mass of sodium. So 2 times 22.990 grams of sodium. That accounts for all the sodium in my sodium carbonate. To that, I'm going to add 1 times 12.011 grams of carbon to account for all the carbon in that 1 mole of sodium carbonate. And then I'm going to add 3 times 15.99 grams of oxygen to account for all the oxygen in that 1 mole of sodium carbonate. If I add all those together, I get 1 mole of Na2CO3 is equal to 105.988 grams of Na2CO3. That is the molar mass of sodium carbonate, and we could use that in our dimensional analysis just like any of the other molar masses we have used. Let's try some other compounds. Let's do an organic compound, propane. According to our organic naming rules, propane is C3H8. So carbon, look on the periodic table, 1 mole of carbon is 12.011 grams of carbon. Hydrogen, 1 mole of hydrogen is 1.0079 grams of hydrogen. If I look at the formula, 1 propane has 3 carbon, and it has 8 hydrogen. So that means the molar mass is going to start with 3 times the molar mass of carbon, and I'm going to add to that 8 times the molar mass of hydrogen. So if I do my math, I see that 1 mole of propane is equal to 44.096 grams of propane. And that would be the molar mass that I could use in my dimensional analysis. This works for covalent compounds as well. Carbon tetrachloride, according to the names for carbon tetrachloride, its formula would be CCl4. Carbon has a molar mass of 12.011 grams per mole. Chlorine has a molar mass of 35.453 grams per mole. If I look at the formula, carbon tetrachloride has 1 carbon, and it has 4 chlorine. That means when I figure out the molar mass, I take 1 times the molar mass of carbon, and 4 times the molar mass of chlorine, and add them all together to get me a molar mass of 141.812 grams per mole of carbon tetrachloride. This works for anything that we can write a formula for. So let's do an acid. Sulfuric acid. Knowing our nomenclature rules for sulfuric acid, we know that the formula becomes H2SO4. So let's look at the periodic table. Hydrogen. 1 mole of hydrogen is 1.079 grams of hydrogen. Sulfur. 1 mole of sulfur is 32.065 grams of sulfur. Oxygen. 1 mole of oxygen is 15.999 grams of oxygen. Formula for sulfuric acid says that there are 2 hydrogen, 1 sulfur, and 4 oxygen found within that compound. So I take 2 times the molar mass of hydrogen. To that I add 1 times the molar mass of sulfur. To that I add 4 times the molar mass of oxygen, giving me a final molar mass of 110.088 grams per mole of sulfuric acid. You should be able to perform this process for any chemical that you can write a formula from. This ends the module on dimensional analysis for finding the molar mass of compounds.